In Lesson 4, we can start by looking at the warm-up. At the end of the day, you need to know the location in both degrees and radians of your unit circle values. If you are asked to evaluate any trig function, which is not on the unit circle, you're going to use coterminal angles to add and subtract revolutions of either 360 or 2 pi to get back to the corresponding unit circle value. If we look at the first example, the sine of 120 means we're going to first find the y value at 120 degrees. So with a quick sketch, 120 degrees is going to put us up here in quadrant 2. The y value is a whole lot of y in the positive direction, which results in root 3 over 2. The next example is secant. Secant, your thought process should involve secant going back to cosine. By definition on the unit circle, this is 1 over x. Secant is defined as 1 over x. The x value at 5 pi over 6 is a whole lot of x, which is negative root 3 over 2. 1 over negative root 3 over 2 has to be simplified. We take 1 and multiply by the reciprocal of the denominator, and then we rationalize to get our final answer. So the secant of 5 pi over 6 is negative 2 root 3 over 3. Negative 5 pi over 3 is not a unit circle value until we add or subtract revolutions to get us back to pi over 3. We're looking for the cosine, which is the x value at pi over 3. Again, pi over 3 is located here. Tangent of negative 390, adding and subtracting revolutions takes us to tangent of 330. Tangent on the unit circle is defined as y over x. 330 degrees is going to be right here. The y value is negative 1/2. The x value is root 3 over 2. Both of the division by 2 can be canceled, which leaves you with negative 1 over root 3, which we then rationalize into our final answer. If you recall, in the parts of a trig equation, we have the trig function out front, followed by the angle. For the next few problems that you have in this section, the angle will be represented with either t, which will be in radians, or the angle will be in theta, which indicates that we should think in degrees. The right side of our trig equation will always be the ratio of the sides. Whatever is written there should be able to be expressed as a number divided by another number. If we talk about the concept of this lesson, you're asked to solve for t. This is a trig equation where the unknown happens to be the angle. T means we're thinking in radians. What this is saying to you when you read it is, where on the unit circle do I have a cosine, which is the x value, that is positive root 2 over 2? Geometrically, that exists at the 45s in quadrants 1 and 4. However, since we are dealt with a variable t, we want to think in radians. Pi over 4 and 7 pi over 4 are the two locations of those dots in the coordinate plane. However, notice the notation of plus or minus 2 pi k, plus or minus 2 pi k. When I read the problem, there were no restrictions on only giving the answers on one revolution of the unit circle. Therefore, if we start at pi over 4, that could be one answer. But we could also do a full revolution, which is 2 pi when k is 1, and then come back to pi over 4. Or we could do 2 revolutions and then come back to pi over 4. These two solutions include all of the coterminal angles that exist both positively and negatively, where the ending side is coterminal with pi over 4 and 7 pi over 4. If we move to the next section, there are 6 examples. All of the problems that we are going to be given are going to give us restrictions, or restrictions on the domain specifically, and then a trig equation. I like to start always with the restrictions. So I start on the right-hand side and say, well, t, which is going to be in radians, is going to exist between pi over 2 and 3 at pi over 2. I can work in quadrant 2 or 3. Sine is going to be the y value of negative 1. So after I've memorized or thought out my unit circle, I should recognize that this location specifically is going to be right here at the pink dot. The answer to this problem then is going to be 3 pi over 2, which does fall in the acceptable interval that's given. Moving to example 2, I'm going to also start with the restrictions of 270 to 360. That's going to be quadrant 4. Cosine is going to be the x. So I'm looking where I have an x of 1/2, no matter what y is, because everything is restricted since we're dealing with unit circle values. The location on the unit circle of x as being 1/2 is going to be right here. Now notice I switched to theta. Even my restrictions are in degrees, so my answer also must be in degrees. 300 degrees is in the interval. It's the location of the pink dot. In example 3, I once again can start with my restrictions, which are between pi and 2 pi. Now, be careful on this one. Tangent is -1. Tangent in the unit circle is based as y over x. Y over x equal to -1. Well, first of all, tangent is negative when I have opposite signs. So I know that now I must have an answer that falls in this shaded region. Over here, tangent is positive. This is where tangent is negative. Y over x is equal to 1. The ratio of sides is -1. That tells me that these two have to be the same number. I can't use 0, 1 or 1, 0 because those do not simplify to 1. The only place on the unit circle that happens is the 45, which is going to be located in quadrant 4. In this case, t is going to equal 7 pi over 4. In example 4, again, I'm going to start with my restrictions. This is the first problem we've come across where the restrictions are outside of a typical single revolution of the unit circle. 2 pi to 3 pi. So keep in mind, we're going to have a revolution around to 2 pi. The answer is going to lie beyond that single revolution. Cosine is going to be the x value of -√3 over 2. That exists over here on the unit circle. In your head, if you know your unit circle, t is going to be 5 pi over 6. The problem is the answer is not 5 pi over 6 because 5 pi over 6 does not fall within this interval. T is going to equal 5 pi over 6 plus 2 pi, or 17 pi over 6. I need to include the full revolution plus 5 pi over 6 more. Example 5. This is going to take into account a lot. 6 pi to 7 pi, 2 pi, 4 pi, 6 pi is 3 revolutions. Then I'm going to come up here. Somewhere between 6 pi and 7 pi, my solution will fall. Now, for the next step, there's a lot of thought process that needs to go on in our understanding of the unit circle. First of all, 2√3 over 3, before it was rationalized, was 2 over √3. Secant we know is 1 over x. Secant goes back to cosine. So this actually was 1 over √3 over 2. X is positive, which means it has to fall in quadrant 1. X is not negative. So where do I have an x value of √3 over 2? Right here at pi over 6. Pi over 6 is not my answer though. T is going to equal to pi over 6 plus 6 pi, the original 3 revolutions plus the unit circle value. This gives me a final answer of 37 pi over 6. The last problem is 270 to 450. 270 to 450 is somewhere in either of these two curves. But remember, this piece in quadrant 4 is still the first revolution of the unit circle. The piece up top is going to be a secondary portion of the next unit circle revolution. Since cotangent is positive, we know that this has to exist in quadrant 1. Cotangent is a ratio of x over y equal to positive 1, which means once again our ratio has to be the same thing over itself, which is going to be the 45. I'm back to dealing with degrees, so I know that I had to travel 1 full revolution back to 360, but then I need to go an additional 45. So theta is 45 plus 360, or 405 degrees.